So in this lesson, we are going to look at these things called surds. So basically, surds are, we take a number and we write it in this form here. So for example, the square root of 2. So the square root of 2, this is what's known as a surd. And basically, it's like surds are just a way to represent a number, or how to represent a number. So the square root of 2. So if we take a number like the square root of 2, so if I cancel this, and if I get 2 and I get the square root of it, we can see here that the square root of 2, it ends up like a big huge number, what's called an irrational number, that looks something like this. And this decimal place just keeps on repeating over and over and over, and the number keeps changing and changing and changing as we move through the number of decimal places. So this just keeps going on indefinitely. So instead of trying to work with numbers like this, irrational numbers, we can write them in a simpler form like this, which is what's known as a surd. So these two here are equivalent to each other. So 1.414213. So 1.41, what was that? 1.414213. 4213. Okay, and then we can just write dots like this to indicate that this is continuing on indefinitely in that direction. So this number here is equivalent to this. So there's loads of different ways that we can write numbers or represent numbers, and surds is just another way that we can represent a number. So if we take a number like this, so this is a number that's in fraction form, and we can write this in decimal form. So we can write it like this. So 7 divided by 8 is equal to 0.875. So we can just write it like this, 0.875. Okay, if we take this number here, so 1 over 3. So let's check what that is. So 1 divided by 3. So that's equal to 0.3, and the 3 just keeps repeating on and on and on. So we can write it like this, 0.3, and then we can write a little circle over the 3 like that. That indicates that the 3 is just repeating on and on and on. 2 is just equal to 2. 3 over 11. So if we take this number 3 over 11, that's equal to 0.27, and then see the way the 27 just keeps repeating. So it's 0.27. And this 27 just keeps repeating on and on and on. So we can just draw two circles, 2 points over the 27 to indicate that these numbers keep repeating. And then if we take this one here, so 7 divided by 12, or 7 over 12. And that's going to be equal to 0.583. And then the 3 is just repeating, 0.583. So 0.583. Okay, and then we can put a point over the 3 like that to indicate that the 3 is repeating. So again, this is important that you know, for example, what, like when you have a point over the number like that, what it represents. But basically what this means is that we can take numbers and we can represent them in many different ways, and it's all about making it simple. Maths is about making things simplified so that we can work with it. So instead of trying to work with numbers like this, we can write it in surd form and work with it like this. And surds are just basically when it has the square root bracket over it, like so. That's what we're talking about when we're talking about surds. So where can this kind of be useful? Well, if we take something like this, so if we take Pythagoras, so this is Pythagoras Theorem. So it's basically saying that so the longer side here is going to be equal to the sum of the squares on the other two sides. So for example, if we let this side be equal to 1 and we let this side here be equal to 1, then this side here is going to be equal to c. Now let's try and work this out and see what we get. And this will kind of highlight why surds are important. So basically, in order for me to get the length from here to here, I can use Pythagoras' theorem. So the length C is going to be equal to the square root of 1 to be squared plus 1 to be squared. And if we, so this is going to be equal to, so 1 to be squared is just 1 by 1, which is 1, and that's 1 by 1, which is 1. And then if we add the two of them together, it's just going to be 2. So C is equal to the square root of 2. So basically this side here, C, let me just rub this out here, it's going to be equal to the square root. If this side is 1 and this side is 1, this is going to be the square root of 2. Now, the problem with that, as we've seen, when we try and get the square root of 2, so if we take 2 and we get the square root of that, it just ends up as this big repeating number. Okay, so it's very hard to try and work with this. So you can't actually get the distance from here to here in decimal form, because as you get closer and closer and closer to the side, what happens is that, you keep getting another decimal place. So in order for it to be more accurate, what we do is, instead of trying to put it into decimal form, we work with it as a surd, and we write it in this form here. Okay, we write it in surd form. So in order to be able to use like surds, so we need then some rules in order to, when it comes to adding and subtracting and multiplying and dividing surds. So we need to know like how to do that. So what we can do then is we can take surds and we can simplify them. And when we simplify them, they have these two parts. They have what's called the rational part and they have the irrational part, and we'll talk about this. So the rules then in relation to working with surds. So the rules. So the first rule is, if we have, so the square root of AB, now that means the number A multiplied by the number B, that's the same as, or is equal to, the square root of A multiplied by the square root of B. So let's look at an example of that. So if I take this here, okay, so this is a surd, so it's the square root of 8. Now what I want to do is, I want to write this in its simplest form, or I want to simplify it. So how do we do that? Well, okay, so what we do is we can write it, first of all, we can write it in this form. So what would that look like in this form? Well, we can write it like, what are the factors of 8? So for example, we have 2 and we have 4. So we can write it as the square root of 4 multiplied by the square root of 2. Okay, so it looks something like that. Now, what we're going to end up then is, we're going to end up with, so this here is the rational part. Okay, so the rational part. It's rational because you can actually get the square root of 4. It's just equal to 2. And then you're going to end up with this part here, which is the irrational part. Okay, so it's going to have, when you simplify a surd, it'll end up with these two parts, the rational part and the irrational part. So we can continue on simplifying this. So the square root of 4 is just equal to 2 times the square root of 2. So now what we have is, we have these two parts. So we've taken this surd here and we've simplified it, and we've written it like that, and we've used this rule here. So this is the first rule of, when we're working with surds, this is the first rule that we can use here. So again, when you simplify a surd, you end up with the two parts. You have the rational part, which is 2, and then you have the irrational part, which is this number here. Why is this the irrational part? Well, if you try and get the square root of 2, it ends up as this big decimal place number. So again, if we do the same with this guy here, so 48, so the square root of 48, and we want to simplify that. So again, we can use this rule up here. So think about, what are the factors of 48? So a factor pair, you could have 3 and 16. So we can write it like this. So you have the square root of 16 multiplied by the square root of 16 multiplied by the square root of 3. Okay, and then if we simplify that even more, it's going to be equal to the square root of 16. So the square root of 16, let's get that. So that's going to be the rational part. So 16 to be squared is just equal to 4. So it's going to be equal to 4 times the square root of 3. Okay, so again we have the rational part and the irrational part. So that is the first rule, and that's to take a surd and simplify it. Okay, so that's the first part. So the next one then is the division. So if we have something like this and we want to write this in simple form, so again the same, we have this rule here, so it's going to be, so a divided by b to be squared is equal to the square root of the top part, which is a, divided by the square root of the bottom part, which is b. So it looks something like that. So if we take this guy here and we simplify it, what's that going to be equal to? So it's going to be the square root of 17 divided by the square root of 9. And then if we try and simplify that some more, so we can't, this is the irrational part, so we can't simplify that anymore. So we just keep it like that. And then we simplify the bottom part, square root of 9, which is equal to 3. Okay, and that's the second rule here. So that's this guy here. So that's just taking surds and simplifying them. Now, so it's important that you're able to do this when it comes to surds and being able to simplify them, because this enables you to do the next part. So the next part then is adding and subtracting surds. So let's look at this example here. So when we're adding and subtracting surds, so surds can only be added or subtracted when they have the same irrational parts. So what we have to do is, in order to be able to add these three surds together, we have to change them so that they have the same irrational parts. So let's have a look at this. So if we take this first surd here, so we can't really simplify this anymore. So it's going to have the two parts. So when you have like just a square root like this, just on its own like that, it's implied that there is a 1 in front of it. So this 1 is going to be the rational part, and then this 5 is the irrational part. So we can't simplify this anymore. But what we can do is we can move on to this one and we can start to simplify it. So what's another way we could write this? So we can write it in this form. So we can write the square root of, so what are the factors of 45 if we have 5 as one of the factors? So what's the factor pair? So we have 9 multiplied by 5. Okay, so we can write it like this. So 45 is the square root of 45 is equal to the square root of 9 multiplied by 5. And then using this rule, we can write it in this form. So that's equal to the square root of 9 multiplied by the square root of 5. So the square root of 9 is just equal to 3. And the square root of 5 is 5. So it's just going to be the square root of 3 multiplied by, so 3 multiplied by the square root of 5. So we've taken this surd here and we've simplified it into this guy here. Now we can do the same here. So this is subtract, so minus. So we want to write this in this form first. So, and we want to keep 5 as one of the factors. So it's going to be 4 multiplied by 5. So again, we can use this rule and write it in this form. So it's going to be equal to the square root of 4 multiplied by the square root of 5. And then what we can do is we can get the square root of 4, which is just 2, multiplied by the square root of 5. Okay, so now notice that if I just write this out over here now, so we have 1 times the square root of 5 plus, so the square root of 45 can be simplified into 3 times the square root of 5. And then the 20, then the minus 20. So this here can be written in this form here, 2 times the square root of 5. So 2 times the square root of 5. So now notice that, so it says that in order to add or subtract them, they all have to have the same irrational part. So basically these 3 surds here, you have to write them in a way so that they have the same irrational part. So this is the irrational part here, the 5. So notice that's the same for each. And then what we can do is we can add up the rational parts, which is this number, and this number. So it's going to be equal to 1 plus 3, which is 4, minus 2, which is equal to 2. So it's going to be 2 times the square root of 5. Okay, so that is adding and subtracting surds. So you have to change them into a form so that they have the same irrational parts, just like what we've done here. So the next piece then to look at is multiplying surds. So when we're multiplying surds, so for example we have two surds here and we want to multiply them by each other, we multiply the rational parts by each other and the irrational parts by each other. Okay, so if we take the first one here, so again it's going to have its two parts. So remember, it's implied that there's a 1 in here in front of this, like so. So we multiply the rational parts, 1 by 1 is just going to be equal to 1. And then the irrational parts, so 3 multiplied by 6 is just going to be equal to the square root of 18. Okay, so it looks something like that. So again, this one here, so again, we multiply the number part and then the square root part. So 2 by 3 is just equal to 6. And then 3 by 5 is equal to the square root of 15. Okay, so it looks something like that. Now this one here, so what we want to do is we want to multiply these by each other. Now you can just multiply 32 by 48. So 32 by 48. So 32 multiplied by 48. And that's going to be 1536. So it's going to be equal to the square root of 1. So 1536. So 1536. Okay, but it's going to be very hard to try and simplify that then. Okay, in trying to simplify that would be next to impossible. So what you can do is you can first of all simplify these and then multiply them by each other. Okay, so let's do that over here. So if we take, so for example, the square root of 32 multiplied by the square root of 48. So let's try and simplify this. So what we could do is we could write this as, so you could write it in simple form. You could take, so for example, so 16 and 16 is 32. So you could write it like the square root of 16 multiplied by 2. Okay, and then using this rule, we can write that then as the square root of 16 multiplied by the square root of 2. Square root of 16 so the square root of 16, so 16 is equal to 4. So the square root of 16 is just 4, so that's going to be 4 times the square root of 2. And then we can do the same with this, so that's going to be, if we take 16 for example, so it's 4 16s, so it's going to be 16 multiplied by 4. So 4 16s is 48. And then we can write that as the square root of 16 multiplied by the square root of sorry, now this should be not 4, this should be 3. And then we have, so the square root of 16 multiplied by the square root of 3, and that's going to be equal to 4 multiplied by the square root of 3. Okay, so it looks something like that. So we have the square root of 4 multiplied by 2 multiplied by 4 times the square root of 3. So again, now we can just multiply. So 4 by 4 is 16 times the square root of 6. Okay, so that's, instead of leaving it in this form, we can simplify each of these and then multiply them by each other. So you multiply the rational parts by the rational parts, the irrational parts by the irrational parts. And that's what it looks like. Okay, so that's it in its simplest form. So that is surds. So we've looked at surds, we've looked at the rules of surds, we've looked at how to simplify surds, how to add, subtract, and multiply surds by each other. Okay, thank you for listening.